Yesterday we did slide 13, so now we are finishing up the rest of the slides. So look at the slide that says effects on the quadratic parent function. Y equals x squared is the quadratic parent function. So let's look at what x squared is. So go to y equals, and let's put it in. Just x squared. That's our quadratic parent function. It's the most basic quadratic function. Hit graph. Okay, so this is the most basic. It goes through the origin, and it's symmetrical about the y-axis. The vertex is at the origin, and its line of symmetry is the y-axis. Need to have y'all's screens closed. You don't need them open right now. A transformation is a change to the size or location of a figure. So every quadratic function comes from its parent, y equals x squared. And so there's some kind of change that happens to this. So let's go to the next page over here. And let's do a little bit more on the quadratic parent function, y equals x squared. Complete the table to make an accurate graph of the quadratic parent function, y equals x squared. So let's go to our table, and let's fill in the table that is on our paper. And let's graph. So we have 0, 0. This is our vertex. See how our vertex is 0, 0, and then if you look at your y's increasing on the x side, 1, 4, 9, 16. And then decreasing, you'd have 1, 4, 9, 16. See how it's symmetrical on the table too? Let's go ahead and graph it then. 1, 1, 2, 4, 3, 9, and 4, 16. Go ahead and connect the dots. So see how it's symmetrical on the y-axis? This is your axis of symmetry. Splits it in half, right down the middle. If you want a marker or highlighter, you can go get one if you want. You don't have to. Okay, so with your table group, you are going to compare each one of these. See how the y1 is our quadratic parent function, and then y2 is a new function? You're going to sketch the graph and then also explain what is the transformation. Okay, so go ahead and do that. You have 7 of those. You're going to sketch it, okay? And then you're going to write what the transformation was. And then on the back, there's 2 more. And then you're going to describe the effect. So that was how was it changed on the back. This is more of the summary. And then do your domain and range. So I'm going to give you some time to work on that. Let's go over how you did. Okay, so the first one is just flipped. Right? Or reflect. Reflect is a much better math word. Okay. The next one, translate up 4 units. Right? Okay. The next one, translate down 4 units. My sketches are pretty rough, but you get the idea, right? Okay. The next one, left 4. Then right 4. And then this one is narrower, which is called a stretch. And this one is wider, which is called a compression. It's compressed. Huh? So think about if you have something like this and you compress it, you're squishing it down. That's a compression. Okay, and then you do your domain and range. For each one of these, I went ahead and wrote everything down. I'll put on here stretch, compression. Yeah. And then domain on each one of these is all real numbers, but range is affected because of where the vertex is, how it's moved. So the only one that is less than is this one because it was reflected. The rest of them are all greater than or equal to because they're going upward. So this is just where is the vertex on the y's, or your minimum maximum kind of thing. Okay, let's go to the front. Not the front one, the first page we were working on, so we can finish that. Okay, so the quadratic parent function. So when we have y equals x squared, it's in the vertex form. How does A affect our function? So that would be, if it's negative, it's reflected, right? So if A equals negative, reflect. So it's going to be like this. Okay, and then the other one that we need to put in here is whether it becomes narrower by stretching or wider by compressing. So if the A value, You don't even look at the positive or negative. You just look at the A value. If the A value is greater than 1, it's a stretch. It increases. It's really skinny. So if A is greater than 1, that means it's going to be a stretch. If you want to put on there narrow or skinny, you can. If A is less than 1, it's going to be compressed. It's going to be fat. Then the H value, that is what translates it left and right. K is translates up or down. Okay, so let's look at each one of these. Graph each function. How does it change? How does the graph of the equation change? So this is your homework, these two examples. Right, what A does, and if it does anything, H and K. So remember our vertex form. It's y equals A, x minus h squared plus K. You're going to write your A, H, and K, and then tell how it changes your function.